Hello. So today I will show you what did we get from our Hello. Hello everybody. So exactly as I told you, I'm going to do the rest of the exercise by myself, and then you can simply watch the movie, because some parts of this procedure, they are a little bit of time consuming, so in order to save your time a little bit, you can simply forward the things which do not require your attention, like for example making solutions or waiting until the sample is ready in the furnace, for example. So I think it's going to be better. So first, what I will do, I will take the glass for the furnace and I will wash it with the acetone. Why? Because usually I was touching this with my hands. Of course, hands can be dirty of some oil or other things. So, as you know, the temperature in the furnace is very high. We are going to set it for, I think, 700 degrees. As I told you also previously, it's the maximum temperature of this furnace here. And we can leave this temperature. However, we could have set higher temperature in another furnace, but I think we don't require such high. So our sample will be placed in such a small vial, small container. It is made of the quartz, exactly as the entire vessel for the furnace. Why quartz? Because it can withstand higher temperature than the ordinary glass. I remember that I was also showing you this. This is the quartz glass. It can withstand to several hundred degrees. 700, I think it's okay still. And not more than 1000 for sure. If you want to go for higher temperature like 1000, then you probably need to use some nickel. Nickel is, of course, more resistant for the temperature. I think like maybe 2000 or something. So also I'm going to wash this glass out of any oils which could be due to manipulation with the hands. Okay, so I believe that inside it is clean already. Okay. I can try to wash it, no matter what is. Okay, so this is what we've got. And now the sample. So you remember what we were doing for our soft templating method. Right now I can see that everything is removed from the whiteboard, but I decided to put everything in this Petri dish. Why here? Because it's large surface area and the evaporation would be then easier. You probably can see inside. Of course, it doesn't look like carbon because it's only the precursor mixed with the salt. So it's almost dry, not yet, but almost. So now what I'm going to do is to scratch everything. To scratch everything as thoroughly as I can. It looks like honey a little bit. And then I will put this into this small beaker which I was showing you before. Nice. Okay, I didn't record you this step where I was adding sodium hydroxide to this sample, as you remember, for the equilibration of the pH until the value of 5. But I believe, as you can imagine, this step, it was quite easy. Simply I was adding solution of the sodium hydroxide inside. Okay, so everything is almost transported inside. I would like to put there as much as I can. Okay, the smell is like some kind of the solvent, the organic solvent. Okay, so everything gets inside, and now I will gently put it inside to the bottom of this one, like here, and now the other part with this small tube going inside, like here you can see. And now the nitrogen is going from the inside everywhere, just to avoid burning of the sample. Okay, so now I will move the camera here, and I'm going to put this inside the furnace. So now what we should do, of course, connect the gases. But before we do it, it's better to turn on the gas first. And if we have the stable flow rate of gas, we can already connect the tube. So open the gas. I have previously set it to the correct flow rate, maybe higher. Okay, so it's about 0.3 liters per minute of the nitrogen. So, of course, we connect first tube going inside deep to the sample. Okay, and as probably there will be some exhaust gases going out, I will connect this filter on the other side. Yes, the filter is filled with some oil, so eventually if there is the production of some organics, they will be dissolved in this oil. As you can also see, the oil is bubbling slightly. Yes, you can see. So it means that the nitrogen is successfully flowing through the system. So I would like to give some time to completely exchange the air from the inside for the nitrogen. So as you see, that flow rate is about 0.3 liters per minute. So everything should be actually replaced inside within few minutes. So very, very fast. So right now the next step is to turn on the furnace. So the control unit for this one is a little bit further. So I will also show you how do you operate, because it's not very, I mean it is easy, but okay. So here we can set up different programs, and actually I can remember that previously on our previous experiment where we were carbonizing the biomass, we were also using this. So I'm not going to explain everything, just I will show you the final step, okay? Okay, 700. So right now the time, how fast are we going to reach it, this temperature? Oh, so I think that if you want to go 10 degrees per minute, so we have 70 minutes. So I would set it for 1 hour. Or 30 minutes. Or okay, 1 hour. Or 45 minutes, just to be in the middle. Why I selected this? Because first I don't want it to take so much time, and secondly I don't want it to be too fast, because if it's hitting fast, then the stresses within the glass can be so high so that the glass can break. Because you know that for heating the glass, usually one should apply temperature ramp, which is not very sudden. Okay, so now the time of the reaction will be 1 hour. Safe, safe. Okay, so now let's preview. 700 degrees, 45 minutes to reach, 1 hour of constant temperature, and that's all. So we are all set. I started, and now we can wait for the effect. So of course I'm not going to record this all of this time, because there will be no memory left. Simply I will show you some shots during this will be done. Of course we have also not set the time of cooling down, I mean the going down to the room temperature, because it has no possibility to cool, okay? It is only for heating. The cooling is simply just by itself. Okay, so let's go back. So this is our system. Right now there's nothing really spectacular happening. However, if it will reach some higher temperature, probably some fumes will be evolving. So at that time I will turn on the camera. So see you later. So for the moment the temperature is about 400. Yes, it's just past 400 degrees. So you can probably see already some water accumulating here. So it means that this part is actually not very hot. The hottest is inside, where our sample is put. So in short time I will come here to see what happens again. So the temperature for the moment is 586 degrees, and you can see already something is happening. I don't know exactly at which temperature it started to evolve the fumes, but probably not very fast. So if I make the zoom, you can see this. Okay. So owing to this fact that we have the nitrogen flow, we can easily get rid of this of these gases which are formed. And now all of the substances are transported to the filtered, and there is also evolution of some fumes outside. But if we are under the fume hood, everything is really safe. So just to be even more safe, I will close this door. And now we are waiting for more than 1 hour. Okay, and very important information is that okay, it works. Right now we are after the reaction. The temperature has dropped to 370 for the moment. So I think that soon I'm going to be able to touch it. Yes, it's warm, but I can use some gloves and then I can put it outside. So I'm going to close the nitrogen flow. Okay, then disassemble the hoses. Very carefully not to break the glass. Okay. Okay, this is still very, very hot. You can see that it is black. So it means that there is only carbon which is left, I hope. So I can leave it like here for the moment, and then after it cools down I can take the material from the inside. So let us now open. What do we have inside? Okay, so I'm going to take something to put it on. And of course, let's take our product. So this is our product. It's black, as you can see. So I hope that we are succeeded. So right now, according to the manual, to the experimental part in the publication, we need to obtain this product from here, and also get rid of the templating salt, because you know that the inorganic salt will not decompose. It was just melted to create this porosity, but it is still inside. So as this is salt, it's very easy to get rid of it just by refluxing this with water. So this is what we are going to do. So right now I'm going to the place in the laboratory where we can do it. So for this we will use the vacuum filtration again. You remember we were doing it also before. So in that case I will take this device again. I think I can do it. Okay, so like that, and the membrane, which is going to be made of cellulose nitrate. Okay. Okay, just need to find it here. Okay, it's probably, yes, there is some. Okay, so I will put it just here. Then I can screw this upper part, and now connect the vacuum and this to the other side, just to make it leak proof. Okay, so done. Okay, I need some tools to get our product out of the quartz thing. Okay, so the product looks to be like it's quite soft and powdery. Maybe you can hear it, I don't know. And the consistency is very resembling the one of activated carbon. So I will put it here. And now I will take the water to filtrate. So as you remember, initially we filtrate with just the tap water, and after, for last filtration steps, because we are doing this at first for 3 times, and last time we are taking the distilled water to be sure that there will be no ions remaining. Okay, so I'm turning this pump on. And it filtrates very nicely. want to get rid of any inorganic impurities, get rid totally of this salt, because this is going to be a problem for us later. Okay, so for the last step, I'm going to use the distilled water just to remove any tap water from the inside first, and then I'm going to use the ethanol just to replace the water for ethanol. Why? Because the ethanol has lower boiling point, and it will be easier for me to dry the carbon after that. Okay? We could not use ethanol before because we had to use water just to dissolve the salt which was remaining. But now we can use ethanol. Yes, there is some problem how to get this one off. Okay, it goes. Okay, so I will open this now. To take our product from this filtration thing. Okay, it needs to be done carefully, just not to split it, because it would be anode. Yes, this is how I'm going to do it. Okay, good. So the product is ready. Oh, you don't see it? You see it here. And now I will take the oven. I will use the oven just to evaporate everything. Okay, I will use the other one. This is busy. Okay, good. So you saw the production of templated activated carbon, and just for you to believe that we have produced a high quality carbon, we are going to characterize this one during next semester. So thank you for watching this, and thank you.